In the exercise 406, we talk about a probability tree. Now, it looks like a tree diagram, but there's a very important difference. So, just be aware of that. The structure is basically the same in that you start with your dot and you have branches going sideways, and you have headings, event 1, event 2. However, as you can probably see here, there are numbers actually written on each branch. And what those numbers represent are the probability of the particular outcome. Now, also, an important thing to realise with a probability tree is that they're very, very good in situations where we can talk about an event and then its complement or its opposite. So if you can reduce the situation down to just maybe 2 outcomes, an event, and then just pool everything else into the second branch, then probability trees are fantastic. You will lose a bit of individual information, but if that's not important, then you will find yourself using a probability tree quite often. So as you can see here, it's a situation about a target, and maybe we B can represent actually hitting the bullseye, and then not the bullseye covers every other option. These probability trees are also really good for 3-4 child families, because we only have 2 possible options, a boy and a girl. They're also very good for when we're rolling a dice. If the only outcome that we're interested in is getting a 6, then we can pool everything else into the second branch and call it not a 6. So we've been able to categorise our outcomes into just 2 branches. Now, like I said, we're going to be writing the probability on each branch, because as you know, not all branches now are equal in probability, because if I'm talking about the probability of getting a 6, then we know that is 1 in 6, and everything else other than a 6 would have a probability 5 on 6. Sorry about that announcement. So some key things to note will be it's really good because it can reduce the size of the diagram. We don't need as many branches. We're just going to reduce it to maybe 2 branches if we possibly can. But by doing that, not all branches are equally likely, which means we have to write the probability on each branch. And remember this complementary fact, the probability of at least 1 is 1 minus the probability of none. And we saw that back in a previous exercise. The other things to note is the probabilities on a pair of branches will always add to 1. So here we've got another pair, and 0.1 and 0.9 add to 1, because we're covering all options, an outcome and its complement, or not that outcome. So we just have to be really careful. Here in this example, you can see that the probability is not changing from situation to situation, but there will be some situations, like if I was withdrawing multiple cards from a pack of cards, each time I take a card out, in the next selection, the probability will have changed because there's a card missing. I'll stop the video here, and I'll do this example in another video.